Once regarded as the Bank of Presidents, beginning with John Tyler and including Abraham Lincoln, the historic Riggs National Bank buildings were purchased to serve as the future home of the Milken Center for Advancing the American Dream. Situated just 1,500 feet from the White House, the center is made up of 3 buildings along Pennsylvania Avenue, constructed between 1899 and 1904. Grunley Construction was selected to perform the renovations. This adaptive reuse stands in a league of its own, honoring the building's rich history while a state-of-the-art conference center is born from within. In the district, you can only build so high. For Grunley to achieve its clients' goals, we knew we needed more room. It was clear we'd have to go below the surface.
Grunley's been in DC for the past 67 years. The company's been built around doing large, complex construction projects. We focus on historic preservation, phased occupied renovation, new construction, and a lot of adaptive reuse. One of the things that we do as a company is we hire and develop really talented people. And you can see it in our people. Our people are extremely passionate about solving complex construction projects. The more complex, the better. Grunley has a long resume in doing historic renovation projects. It's one of the things I think that really sets us apart from a lot of the competition here in Washington, D.C. We really focus on doing historic preservation, historic restoration type work. In a lot of the historic projects that we work on, it takes an enormous amount of planning and focus before we even get on site. So we spend a lot of time in the pre-construction phase planning on how we're going to execute our work and still protect the historic fabric of the building, all while maintaining a safe job site. One of the niches that we've developed here in Washington, D.C. is that due to the height restriction imposed by the city, is that we have to find new ways and new creative ways to solve problems for our clients. And one of those is, how do you expand a building? How do you expand a building for a client that needs more space? So one of the processes that we've developed is to go below grade, is to figure out how to expand the building instead of vertically, but to go further below grade and add floors underneath an existing building. Specifically, the Milken project is a great example of the type of work that Grunley excels at. Taking a historic building, a historic bank building, and adding floors to the top with this beautiful glass conference center above the building, and then expanding the building footprint by going below grade and adding floors underneath the building is a great example of how we can tackle some complex construction projects.
I'm Bernadette, I'm project manager with Grunley, and Grunley is renovating 3 bank halls on Pennsylvania Avenue into a museum. And this is a historic building with a lot of historic fabric that we need to really protect. And one of the client's requests was we add square footage and do that by going below the surface. So we weren't touching any of the historic fabric, but building this new theater below grade. So in order to do so, we temporarily supported this beautiful historic building, and we are digging down to be able to build this new theater space. The overall Milken project includes multiple phases. Phase 1, which is an office building, Phase 2, which is historic bank halls, and Phase 1.1, which is some fit-out spaces for the office building. So Phase 2 specifically has multiple parts to it that are really intricate and detailed. The basement, which is actually supporting the entire building, the entire historic building as is, and digging out the foundation from under it and going down a story below, and then pouring back the foundation without moving the building at all. We are turning an existing bank vault into a donor room. Additionally, we're adding a story above. We're adding a glass 6th floor addition and turning some attic space above historic plaster ceilings into usable museum space. So in order to do that, we actually have to remove the roof off of the historic plaster ceiling, protect that historic plaster ceiling, and then build on top of it. So there's a lot of temporary structures that are involved with protecting that plaster ceiling to maintain these beautiful historic bank spaces and turn them into museum space. One of the really interesting parts of this project is building the theater below the existing building. And in order to do so, we're not moving the building at all. We're shoring it and demoing the foundation out from under it and pouring it back. So from the street, it seems very nondescript. You don't see much changing at all, but really below the surface, we are building this theater, doing all this really intricate work, spending years doing this foundation work to build this historic theater.
Just so many challenges with building underneath the existing historic building. The site logistics is really one of the most difficult things that our challenge here. All this equipment, you can't get big equipment down here. You're using little mini excavators, bobcats to move all the material, to move all the dirt, all this excavation. So site logistics is really the most difficult thing that we deal with day in and day out.
So one of the challenges that we came across in this project is the elevation that we had for the 3 separate buildings. We're standing in 1503. We started at a ceiling height of 11 feet. And right now we're approximately down about 30 feet from the original elevation. That was a huge challenge because we had 2 drill rigs that we had to bring in to allow us to drill down 85 feet. Now, we had a headroom issue there. That headroom issue minimized us with the actual pile that we had to use. So, long story short, we went from a 5-foot casing to a 3-foot casing at different locations. So we were standing here in 1503, we used a variety of pile casing. So we started out with 5, went to 3, based on the height ceiling that we had throughout the entire building. So that was challenging. And not just that, also, if you look behind me, we had load-bearing walls that were in our way that we had to kind of work around, try to work past and also reshore to allow us to drill 330 micropiles in this basement.
If you've ever seen micropile work, it's messy, it's wet, and it's sloppy. Trying to get all the dirt out. We had 3 different water containment that we would filter the dirt and get the water out, and then we'd have to scoop all the dirt out into a dumpster. It was a lot of work to get where we are right now.
So BIM's really been an integral part of the project and really helping us in the planning process and the coordination process, both from a scanning of the existing structures and incorporating all of those unforeseen conditions into the model that we can get ahead of when it comes to MEP trades or finishes trades. Also, by doing a 4D schedule, we were able to incorporate all of the temporary structures into the model and plan access accordingly, especially when you have these historic buildings. Access and site logistics can be really challenging. So being able to incorporate that and visually see as much of it as possible in advance while you're putting together a schedule can be really important in preventing potential issues down the line. We're also doing our BIM coordination for all of our MEP trades, which is allowing us to plan for the structure that's going back. A lot of the under slab coordination is ongoing, and to be able to, as we're building up through the building and incorporating into this existing structure, we're able to really get ahead and prevent a lot of issues in the field that we wouldn't be able to know or foresee or plan visually beforehand. So BIM's really been an integral part of this process for us in this historic building.
During 2020, we ran into a lot of challenges. One of the challenges was we were working through the underpinning pits, and then COVID hit. We were asked to decrease our manpower. Our manpower went from 12 underpinning pit crew to 5. But we made the decision to show up every single day. We were able to put in 40 underpinning pits that went down a total depth of 18 feet in different locations. And we were able to do that within 4 months and ahead of schedule.